In the previous topics, we have studied some of the properties of some of the properties of colloids. So those properties what we have discussed in the previous video were the kinetic properties. Okay, so now today we'll discuss the optical properties of colloids. Right. So the optical property. When we study about the optical property, so the main thing that comes into our mind is the Tyndall effect. Right. So Tyndall in 1869 observed that if a strong beam of light is passed through a colloidal system, then the path of light is illuminated, right? The path of light is illuminated. So this phenomena is called Tyndall effect, right? So Tyndall in 1869 observed that if strong beam of light, so if you see this figure, so this is your strong beam of light. So this light is passed through a colloidal solution. So this is your light. So this is passed through a colloidal solution. Then the path of the light is illuminated. The path of light is illuminated, and this phenomena is called the Tyndall effect. So this phenomena is due to scattering of light. This phenomena is due to the scattering of light by Tyndall, scattering of light by colloidal particles, right? So this phenomena is due to scattering of light by colloidal particles. So the same effect is noticed. When a beam of light enters a dark room through a slit and becomes invisible. That is what scattering. See, this is your one slit. If a light is allowed to pass through this, so when light enters through this, when a light enters through a small, as we see in the windows, right? Whenever the light enters through a small opening of the window, which is we call it a slit, right? So that becomes visible. Similarly, the same effect is noticed when a beam of light enters a dark room through a slit and becomes visible. So this happens, but the reason for this happening is this happens due to scattering of light by particles of dust in the air. So this is what the light is scattered into this colloidal mixture of fluorine water and solution of water and red sugar. So this is what the Tyndall effect, which is the optical property. We can see here one more. So there is a light beam. Example, light beam. Light beam is allowed to pass through the solution which is not visible, and now it is visible here. Right. So this is what fluorine water. The Tyndall effect is the scattering of light by particles. The scattering of light by particles in a colloidal suspension. So that is what Tyndall effect. As we know, Tyndall effect, once if you just moralize, so Tyndall in the year 1869 observed that if a strong beam of light is passed through a colloidal solution, then the path of light is illuminated. So this phenomena is what we call it as Tyndall effect. This phenomena is due to scattering of light by colloidal particles. This phenomena is due to scattering of light by colloidal particles. So the same effect is noticed when a beam of light enters a dark room through a slit and becomes visible. So this happens due to scattering of light by particles of dust in the air. Right. So this is what we call it as the optical property. So usually the useful measure, it is useful to measure size. It is useful to measure size, shape and structure. Size, shape and structure and molecular weight of colloids. Molecular weight of colloids. Right. So this includes light scattering and turbidity. If you see here, so this is a light that is allowed to fall on a pure on a solution, that is what a pure dispersion medium, and passes without deviation, right? So if you see here, this is a light, and this is what the colloidal dispersion is, and light is scattered in different directions, and here the refractive index is changed. So the mechanism involved is light plus dispersed particle gives polarized atoms per molecule. Light plus dispersed particle gives polarized atoms or molecules. Okay, and gives dipoles that emit light in all directions. That is what we call it as light scattering, right? So the mechanism involved is light plus dispersed particle gives polarized atoms or molecules, right? And this molecule gives dipoles and that emit light in all directions. So that is what we call this as a dipole, right? So this is what we call it as a dipole, right? So light plus dispersed particle gives polarized atoms or molecules, gives to dipoles which emit light in all directions, and then light is scattered, and thus light is scattered. So this is one of the properties. This is also one of the properties of colloids. First one is what we study, the kinetic property, and next one is the optical property. So here we study these optical properties are useful to measure the size, shape, structure, molecular weight of the colloids, right? So if you come to other property, as we know that colloidals have some different properties like kinetic property, and what we have studied in the previous video. And this video we have studied what is an optical effect, optical property, which we studied about the Tyndall effect. And now if you come to the electrical property, so the particles of colloidal solution, the particles of colloidal solutions are electrically charged. So the particles of colloidal solution are electrically charged and carry the same type of charge either positive or negative. So the particles of colloidal solution are electrically charged and carry the same type of charge, right? Either normal charge, is a positive charge or negative charge. So the dispersion medium has an equal and opposite charge, just like a dipole, right? So the dispersion medium has an equal and opposite charge. Equal and opposite charge means one is negative and other is positive. So equal and opposite charge, right? So the dispersion medium has equal and opposite charge. So the colloidal particles therefore repel each other and do not cluster together to settle down. So the colloidal particles therefore repel each other because of being equal and opposite charges. They repel each other. The like charges repel, and as we have seen, the like charges will repel and unlike charges will attract. So the colloidal particles therefore repel because some of the particles have same charge, right? The same charge. So that's why the colloidal particles therefore repel each other and do not cluster together to settle down, right? For example, arsenious sulfide solutions, gold solutions, silver solutions, etc. contain negatively charged colloidal particles, whereas ferric hydroxide, aluminum hydroxide, etc. contain positively charged colloidal particles. So as we have seen, the particles of colloidal solutions are electrically charged and carry the same type of charge, either positive or negative, right? So the dispersion medium has equal and opposite charges. That is what one is negative and other is positive charges, right? So the colloidal particles repel each other. Right? Repel each other and do not cluster together to settle down. So for example, if you see, that is what we have seen there. For example, arsenious sulfide solutions, gold solutions, silver solution, etc. contain negatively charged colloidal particles. So what are the negatively charged colloidal particles? The negatively charged colloidal particles are arsenious sulfide solutions, gold solutions, silver solutions. Okay, contain negatively charged colloidal particles, whereas ferric hydroxide, oxides contain the positively charged particles, right? So solutions contain the negative and oxide contains the positive, right? So whereas ferric hydroxide, aluminum hydroxide, etc. contain positively charged colloidal particles, right? So this is what we discussed. This is what we have regarding the electrical property, right? So what is the origin of a charge? What is the basic origin of a charge and a colloidal particles? The origin of a charge and colloidal particles is due to preferential absorption of cations. The origin of a charge on colloidal particles is due to preferential adsorption of cations or anions by colloidal particles. Preferential adsorption of cations or anions. Preferential adsorption of cations or anions by colloidal particles. Right? The basic origin of a charge on colloidal particles are due to adsorption of cations or anions, right? And cations or anions. We know that the positively charged particles are the oxide materials, Oxide materials contains the positively charged particles, and solutions are acidic nature. So solution particles, sol particles contains the negative nature. So the main origin of the origin of charge on colloidal particles is due to adsorption of cations, preferential adsorption of cations or anions by colloidal particles, and also by micelles, right? So micelles are nothing but the lipid molecules. Micelles are nothing but lipid molecules that arrange themselves in a spherical form in an aqueous solutions. Okay, carry a charge on them. So micelles carry a charge on them. So micelles are nothing but the lipid molecules. So lipid molecules that arrange themselves in a spherical form. So lipid molecules that arrange themselves in a spherical form in aqueous solution. Lipid molecules that arrange themselves in a spherical form in aqueous solution carry a charge on them. That is what we call it as micelles. Right. So during the formation of colloids, especially during the formation of colloids, so charge also exists during the formation of colloids, especially by Briggs arc method. So Briggs arc method, right? So Briggs arc method, just we'll see that Briggs arc method in the next coming few slides. So just if you see some of the fundamental point is metal electrodes are dipped into the dispersion medium. So metal electrodes are dispersed into a dispersion medium. Metal electrodes are dispersed into a dispersion medium, right? And an electric arc is stuck between these electrodes. Right? So during the formation of colloids, especially by Briggs arc method, so metal electrodes are dipped into the dispersion medium and an electric arc is stuck between these colloids. So colloidal particles capture electrons and get charged. Colloidal particles capture electrons and get charged. Right. So during the formation of colloids, especially by Briggs arc method, that is metal electrodes are dipped into dispersion medium and electric arc is stuck between these colloids. Right, colloidal particles capture electron and get charged. So this is a mechanism how the colloids are charged. So colloids are charged due to absorption of cations, as we see cations or anions like colloidal particles, and also charge on the colloidal particles due to micelles also. Micelles in the thing were lipid molecules that arrange themselves in a spherical form in an aqueous solution. So those lipids also carry some charge. So that's why you're calling it as micelles. So, and also the origin of a charge is due to the formation of colloids, especially by Briggs arc method. Briggs arc method means the metal electrodes are dipped into the dispersion medium and an electric arc is stuck between these electrodes. In this way also colloidal particles capture electrons and get charged. So this is what the origin of charge on colloidal particles. Right. So what are the methods of preparation of colloids? So there are the three methods of preparation of colloids is by condensation method. The three methods of preparation of colloids by condensation method. There are several condensation methods for the preparation of colloids. So including changing the solvent, including changing the solvent, changing the physical state, changing in the solvent, changing in the physical state, using excess cooling, using excess cooling and using chemical procedures Okay. So the three methods of preparation of colloids by condensation method. The three methods of preparation of colloids by condensation method. There are several condensation methods for the preparation of colloids. Including changing the solvent, changing the physical state, using excess cooling and using chemical procedures. So these are the different methods of preparation of colloids. So This method, the method used to separate colloidal particles from colloids. The method used to separate colloidal particles from colloids is centrifugation. So centrifugation is a method. Centrifugation is a method to separate colloid and colloidal particles. So to remove colloidal particles from a colloidal solution, to remove colloidal particles from a colloidal solution, a special technique known as centrifugation can be used. Right? Centrifugation. Right. So centrifugation is a method, right, to separate colloidal particles. So to remove colloidal particles from a colloidal solution, a special technique known as centrifugation is used. Right. So based on particle size and density, centrifugation has been employed to separate colloids from aqueous solution. So based on particle size and density, centrifugation has been employed to separate colloids from aqueous solution. Thus, to separate colloidal particles, centrifugation is used as a true statement. So centrifugation is a method which is used to remove colloidal particles from a colloidal solution. So centrifugation is an essential method. Now, how the preparation of colloids, right? So we have two main types of methods of preparation of colloidal solutions. We have two main types of methods for the preparation of colloidal solutions. One is by dispersion and other is by condensation, right? So that's what we call the condensation and all, the centrifugation method and all. So in dispersion method, in the dispersion method, a dispersion or disintegration method. Dispersion as a disintegration, as a name itself resembles that. The particles of colloidal salts are produced by disintegration of bulk quantity of a hydrophobic material. So in dispersion method, in the dispersion or disintegration method, disintegration means, as the name itself tells, that disintegration means disintegrating the particles. Particles of colloidal size are produced by disintegration of bulk quantity of a hydrophobic material. Right. So these methods may involve the use of such mechanical methods. So the disintegration, as the name itself we told that disintegration, the colloidal size are produced by disintegration of bulk quantity of hydrophobic material. So this disintegration method includes the mechanical dispersion, electrode dispersion, ultrasonic dispersion, and peptization. Right. So the methods involved in dispersion, disintegration method are the methods that are used for dispersion or disintegration methods for particles of colloid size are mechanical dispersion, electrode dispersion, ultrasonic dispersion, and peptization. So these are the methods that are used for disintegration of colloids, right? So we shall see what is this mechanical dispersion, electrode dispersion, ultrasonic dispersion, and peptization. So in mechanical dispersion, so as mechanical dispersion, if you see here, the substance is to be dispersed is grounded as finely as possible by usual method. So the substance to be dispersed is ground as finely as possible by usual method. It is shaken with the dispersion medium. And thus obtained. In the form of a coarse suspension. This suspension is now passed through a colloid mill. Right? The simplest type of colloid mill, called disc mill, consists of two metal discs. So if you see the figure here, there are two metal discs, right? So there are two metal discs nearly touching each other and rotating in the anti-clockwise direction, rotating in opposite direction at very high speed, right? So at a very high speed, right? So the suspension passing through this rotating disc is exposed to a powerful shearing force, and the suspended particles are apart to yield particles of colloidal size. So colloid mills are widely used in the industry preparation of paints, cements, food products, pharmaceutical products, etc. Right. So the mechanical dispersion involves a driving belt with the two discs nearly touching each other and rotating in opposite direction. The suspension passing through this rotating disc is exposed to a powerful shearing force, and the suspended particles are apart to yield particles of colloidal size. So colloid mills are widely used in the industrial preparation of paints, cements, food products, pharmaceutical products, etc. So this is what we call it as the mechanical dispersion, where we can prepare a colloid, right? So next one is electrode deposition. As you have seen, first one is a mechanical deposition and second one is electrode deposition. So these methods, electrode deposition, these methods are employed for obtaining colloidal solutions of metals. So these methods are employed for obtaining colloidal solutions of metals like gold, silver, platinum, etc. So these methods are employed for obtaining colloidal solutions of metals like gold, silver, platinum, etc. An electric arc is stuck between the two metal electrodes placed in a container of water. Right? So this is what the braid arc method that we have seen in the previous slide. That is what during the formation of colloids, especially by braid arc method, metal electrodes are dipped in the dispersion medium, and an electric arc is stuck between these two colloids. Right. So this is what we are studying about the braid arc method. Right. So in braid arc method, in this method, this is what the braid arc method, that is what we are showing here in the figure, preparation of colloidal solution by braid arc method. So these methods are employed for obtaining colloidal solutions of metal electrodes, we are telling, right? So since we are talking about the colloidal solutions of metals like gold, silver, and platinum, etc. So an electric arc is stuck between the two metallic electrodes placed in a container of water. So this is what we have: an ice bath, we have the dispersion medium, and these are the two metal electrodes, right? So in these two metal electrodes placed in container water, an electric arc is stuck. One is positive, another is negative. So electric arc is stuck between the two metal electrodes placed in a container of water. So the intense heat of the arc converts the metal into vapors. The intense heat of the heat so produced, the intense heat of the arc converts the metal into vapor, which are condensed immediately in the cold water bath. So that's why we are taking it as a cold water bath. So the intense heat of the arc, the heat so generated due to the production of arc, converts that metal into vapors, which are condensed immediately into the cool water bath. Right. So this results in the formation of particles of the colloidal size. Colloidal size. So when we use the metal electrodes, then we call it as a gold solution. So this is what the electrode dispersion. So in the preparation of colloids, electrode dispersion method. So braid arc method is one of the method for preparation of colloidal solutions by colloidal solution, right? So that is what I'm telling again. The methods are employed for obtaining colloidal solutions of metals like gold, silver, and platinum. Because the metal electrode, we are dipping a metal electrode into a water bath and electric arc is stuck between those two electrodes that contained in water. So the intense heat of the arc converts the metal into vapors, which are condensed immediately into the cold water bath. So this results in the formation of particles of colloidal size. So we call it as gold sol. So other method of preparation of colloid is ultrasonic dispersion. So ultrasonic dispersion is nothing but ultrasonic dispersion having a frequency, ultrasonic vibrations having frequency more than the frequency of audible sound. So ultrasonic waves or ultrasonic sounds. So ultrasonic vibrations having frequency more than the frequency of audible sound could bring about the transformation of core suspension to colloidal dimension. Ultrasonic vibrations having frequency more than the frequency of audible sound. So ultrasonic vibrations having frequency more than the frequency of audible sound could bring about the transformation of coarse suspension to colloidal dimensions. So the clause obtained class obtain mercury sol by subjecting mercury to sufficiently high frequency ultrasonic vibration. So class obtain mercury solutions. Class obtain mercury solutions by subjecting mercury to sufficiently high frequency ultrasonic vibration. So this is what we see here. We have a ultrasonic generator, that is what the quartz generator. Quartz generator we have, and an electrical oscillator which oscillate, electrical oscillator, right? So due to this electrical oscillator, the water gets heated up, right? So in this is a water that is get, so this beaker is immersed in a oil chamber, right? In that mercury, right? So that is what ultrasonic vibrations of frequency more than frequency of audible sound would bring about the transformation of core suspension to colloidal suspensions, colloidal dimensions. Class obtained mercury sol by subjecting mercury to sufficiently high frequency ultrasonic vibrations. And next method of preparation of colloids is peptization. So peptization is a process. Peptization is a process of converting a freshly prepared precipitate into colloidal form, right? So peptization is a process of converting a freshly prepared precipitate, into colloidal form, by the addition of suitable electrolyte. This is a suitable electrolyte. So peptization is a process of converting a freshly prepared precipitate into colloidal form by the addition of suitable electrolyte. So the electrolyte is called the peptizing agent. For example, when ferric chloride is added to precipitate of ferric hydroxide, when ferric chloride, FeCl2, iron chloride or ferric chloride is added to a precipitate of hydroxide. So chloride to hydroxide as a solutions to oxides, right? Solution to oxides. So when a ferric chloride is added to when added to a precipitate of ferric hydroxide gets converted into reddish brown colored colloidal solution. So ferric hydroxide gets converted into reddish brown colored colloidal solution. So this is due to preferential adsorption of cations. Of the electrolyte by the precipitate. This is due to preferential adsorption of cations of the electrolyte by the precipitate. So that is what, when ferric chloride, that is FeCl3, ferric chloride is added to FeOH3, Fe iron oxide, so ferric oxide, so that ferric hydroxide. So the Fe3 plus ions form FeCl3 are adsorbed by FeOH3 particles, right? Thus, the FeOH3 ferric hydroxide particles acquire positive charge and they start repelling each other from a colloidal solution. Okay. So this is what one of the peptization method for the preparation of colloids. So that is what we are telling. Peptization is a process of converting a freshly prepared precipitate into colloidal form by addition of suitable electrolytes. So that electrolyte is called peptizing agent. So for example, when a ferric chloride FeCl3 is added to ferric hydroxide, then the Fe3 plus ions form FeCl3 are absorbed by ferric hydroxide particles, and this this ferric hydroxide particles acquire positive charge and they start repelling each other, forming a colloidal solution. So this is what we call it about the peptization method. So if you go to other methods, so what is the dispersion? These all come under dispersion methods. So the dispersion methods have mechanical dispersion, electrode deposition, electrode dispersion, and ultrasonic dispersion, and other is a peptization method. So these are all the dispersion techniques for the preparation of colloids. Right. If you come to condensation method, so in condensation method we use the centrifugation method. So sulfur centrifugation method. So we will see that centrifugation method in the coming videos. So sulfur solution is obtained by bubbling H2S gas. So sulfur solution is obtained by bubbling H2S gas through the solution of an oxidizing agent. through the solution of an oxidizing agent like HNO3, nitric acid, or bromium water, etc. According to this following equation, that is bromium plus H2S. Bromium plus H2S gives sulfur plus 2HBr, and nitric acid 2HNO3 plus H2S gives 2H2O plus 2NO2 plus S. Right. So ferric hydroxide solutions, AS2S, arsenic S3 sulfur solution can be prepared by chemical methods. So this is what we call about the condensation method. So sulfur solution is obtained by bubbling H2S gas through formation of oxidization like HNO3, like nitric acid or bromine water. So the equation related to that is bromine Br2 plus H2S, right, gives sulfur plus 2HBr, and 2HNO3 plus H2S gives 2H2O plus NO2 plus S. So iron oxide solutions, AS2S3 solution, can also be prepared by chemical methods. So this is what the condensation methods is. So how the colloids are purified? So what about the purification of colloids? So when a colloid solution is prepared, it contains some impurities. So the impurities that are when a colloidal solution is prepared, as soon as the solution is prepared, it contains certain impurities. So that impurities are to be purified. So that is what we call a purification of colloids. So these impurities are mainly electrolytic in nature. So these impurities, whatever the impurities, as soon as the colloids are formed, it has certain impurities. As these impurities are mainly electrolytic in nature, and they tend to de-establish the colloidal solution. These impurities are mainly electrolytic in nature, and they tend to establish the colloidal solution. Therefore, colloidal solutions are purified. So the methods used to purify the colloids or purification of colloids are: one is a dialysis method, and other is a electrodialysis. So dialysis and electrodialysis are the two methods to purify the two methods for the purification of colloids. Right. So one is a dialysis method, and other is the electrodialysis method. So if you come to the dialysis method, which is one of the method for purification of colloids, so the process of dialysis is based on the fact that colloidal particles cannot pass through parchment or cellophane membrane, celloplane membrane, while the ions of the electrolyte can. Right, ions of the electrolyte can pass through parchment or a celloplane membrane, while the ions of the electrolyte can. So the colloidal solution is taken in a bag of cellophane which is suspended in a tub full of fresh water. So this is what the dialysis method is. This is what the dialysis bag, right? So the impurities diffuse out, leaving pure colloidal solution in the bag. This process of separating the particles of colloids, the particles of colloids from impurities by means of diffusion through a suitable membrane is called dialysis. Right. So this dialysis is one of the method for purification of colloids. So the process of dialysis is based on the fact that colloidal particles cannot pass through parchment or celloplane membrane, while the ions of the electrolyte can. So ions of the electrolyte can pass through the ions of the electrolyte, while ions of the electrolyte can. So the colloidal solution is taken from a bag, is taken in the form of a bag, is taken in a bag of cellophane which is suspended in a tub full of fresh water. The impurities diffuse out, leaving pure colloidal solution in the bag. So the impurities diffuse out, leaving pure colloidal solution in the bag. The process of separating the particles of colloidal solution from impurities by means of diffusion through a suitable membrane is called the dialysis. And other method is the electrodialysis. So this electrodialysis method, the dialysis process is slow. Electrodialysis process is slow and speeds up its rate. And the dialysis process is slow, and to speed up its rate, it is carried out in the presence of an electric field. So electrodialysis, that's why we call it as electrodialysis, where the dialysis is taken in the presence of electric field. So that the dialysis process is slow, right? So in order to speed it up, we are going for another type of purification of colloid, that is electrodialysis, where the dialysis where we observe where the purification is done in the presence of electric field. That is what we call it electrodialysis, right? So this purification of colloids in the presence of electrodialysis, in the sense when the electric field is applied through the electrodes, when the electric field is applied to the electrodes, the ions of the electrolyte present as impurity diffuse towards positively charged electrodes at faster rate, right? At faster rate. In this way, faster rate due to the presence of because the dialysis carried out in the presence of in this way the purification of colloids can be obtained. So that's what we are telling, the dialysis process is slow and need to speed up its rate. The dialysis process is slow, and to speed up its rate, it is carried out in the presence of an electric field. It's carried out in the presence of electric field. That's why we are calling it electrodialysis. So the dialysis carried out in the presence of electric field is what we are calling it as electrodialysis. That means when the electric field is applied through the electrodes, the ions of the electrolyte present as impurity diffuse towards positively charged electrodes at faster rate. So this is what somewhat similar to the break arc method, right? So this is what you're telling cellophane bag or parchment paper bag, right? And these are the electrodes. These are the electrodes which are given negative, positive, right? And this is what the water that is passed, and solution of solution crystallized crystallized in water, and this is what the tunnel is, right? So in this way, the purification of colloids can be done, right? So if you talk about origin of charge in colloidal particles, the charge on the colloidal particles is developed due to following reasons. So one is due to self dislocation, and other is the presence of acid or basic groups, right? So the charge on the colloidal particles is developed due to following reasons. One is a self dislocation, so other is the presence of acid or basic groups, and third one is selective adsorption of ions. In case of self dislocation, colloidal electrolytes such as sodium stearate, that is what soap, dissociate into solution giving C17H35COOH and Na plus ions. The hydrocarbon parts of the ions have marked affinity for one another. Thus, they cluster together, developing a negative charge on the colloidal soap particles. That is what we call as self-dissociation. So, colloidal electrolytes such as sodium stearate, that is what soap, dissociate in solution giving C17H35COOH and Na plus ions. The hydrocarbon parts of the ions have marked affinity for one another. Thus, they cluster together, developing a negative charge on the colloidal soap particles. So, this is one method how the charges, how the charge of colloidal particle is developed, right? And next one is presence of acid or basic groups. So proteins have in proteins have carboxyl groups and basic amino group, that is what RNH2COOH, right? Basic amino group, that is. So thus in acid solutions, colloidal particles of protein develops a positive charge, whereas in alkaline solution a negative charge is developed due to ionization. And third one is the selective adsorption of ions. In case of selective adsorption of ions, the origin of a charge on the solution particles in most cases has been demonstrated to be the selective adsorption of certain type of ions present in the dispersion medium. The origin of charge on the solid particles in most cases has been demonstrated to be the selective adsorption of certain type of ions present in the dispersion medium. So the negative charge on the metal salts is due to the adsorption of hydroxyl ions furnished by traces of alkali used to produce stable salts. Right. So this is what we speak about the origin of charge in colloidal solution. As we have previously seen also the origin of in the previous slides we have seen the origin of charge on colloidal particles. One is by missiles, another is by break arc method, right? So preferential. So how this origin of charge is, how the charges are developed, origin of charge, that is, and how the charges are developed here. So the charges are developed by self-dissociation and presence of acid or basic groups and selective adsorption of ions. When two or more ions are present in the dispersion medium, selective adsorption of the ion common to the colloidal particles usually takes place. when two or more ions present in the dispersion medium, selective adsorption of the ion common to the colloidal particles usually takes place. When two or more ions are present in the dispersion medium, selective adsorption of the ion common to the colloidal particles usually are taken. For example, the negative charge on As2S3 solution is due to the preferential adsorption of sulfide ions S2 minus produced by the ionization of hydrogen sulfide used in the preparation of H2S, that is 2H plus S2 minus. So ferric oxide solutions is positively charged because of the sole particle absorb the ferric ions in the presence of the chloride ions, right? So ferric oxide solution is negatively charged, right? And solutions are the positive charge and these are the negatively charged. So ferric oxide solution is positively charged because of the sole particles absorb the ferric ions in preference to the chloride ions. So if you talk about the stability of solids, stability of colloids, colloid particles, though larger than ions and molecules, yet are stable and do not settle under gravity. There are at least they do not settle under gravity, right? Colloid particles, though larger than ions and molecules, yet they are stable and do not settle under gravity. There are at least three good reasons for the stability of colloidal solutions. One is by Brownian motion that you have seen. Just that is electric charge, another is solvation. So these are the three reasons why the stability of why the colloidal particles are at stable and do not settle under gravity. One is due to Brownian motion. There is a zigzag motion. So just if you study about the Brownian motion, as you have seen previously, like the molecules or ions in a solution, the colloidal particles of Sol are in a state of continuous rapid motion. So the intensity of Brownian motion falls rapidly with increasing particle size, yet it is high enough to offset of gravity in case of colloidal particles. And the next one is the electric charge. As we know that the colloidal particles in Sol are either positively charged or negatively charged. Therefore, the force of repulsion keeps the particles scattered, and even upon close approach, they will not collide and coalesce. Hence, similar charge on the particles particles of colloidal amounts offer the stability due to mutual repulsion in the solution. And that is a solvation. The colloidal particles of Sol are often highly hydrated in solution. The resulting hydrated called shell prevents close contact and cohesion of colloidal particles. Comparatively, the addition of small amounts of lithophilic colloids called protective colloids. Right, so these are what we talk about the stability of colloids. So that is what colloidal particles, though larger than ions and molecules, colloidal particles are though larger than ions and molecules, yet are stable and do not settle under gravity. So there are at least three good reasons for the stability of colloid solution. One is the Brownian motion, electric charge, and solvation. Right. So these are the three reasons what we can explain regarding the stability of the colloids. So if you come to the advantages and disadvantages of colloids, so they let a disembodiment of insoluble particles such as gold, silver or fat. They enhance the rate of adsorption and can be more frequently used. Right. So this is one of the advantage. What is the advantage of colloids? And disadvantage of colloids are they are arduous to extract and purify. So that is what purification of colloids is one of the disadvantages, because once the colloids are formed, it is very difficult to difficult to remove the impurities as soon as the colloid solution is formed, right? So that's why it is one of the disadvantages. So what are the importance and uses of colloids? So colloid is used as a thickening agent in industrial products such as lubricants, lotions and toothpaste, coatings, etc. In the manufacture of paints and inks, colloids are useful. So in ballpoint pens that we use, the ink used is a gel. It's a liquid solid solution. So some of the examples of colloids are foam, solid foam, aerosols, emulsion, gels, solid aerosols, salts, and solid solutions. So these are some of the advantages and disadvantages of colloids. So one of the basic disadvantages of colloids are nothing but purification. They are arduous to extract. So purification is very, very important. So as soon as the colloid solutions are formed, then there are large of impurities and require so many methods to purify them, right? that is a very rather one of the disadvantage of using colloids. So the advantage is they let dismemberment of insoluble particles such as gold, silver or fat, then enhance the rate of absorption and can be frequently used, right? So these are some of the advantages and disadvantages of colloids. Okay, so we will end up with this colloids part as of today, and we'll start about the electrode deposition method in the next coming videos. Right. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.